Hi students, this is Chapter 7, Part 1, Work Energy and Simple Machines from your Grade 9 CBSE. Now let's understand this chapter in more detailed form, Work Energy and Simple Machines. Now energy, what it is exactly? It is required for every every activity in life. For example, when we talk about food, electricity, fuel, or the key question comes across is that what is work? What is energy? What is power? So for all this, how do machines they make this work easier? Next is work done by a constant force. Now work done is basically students, it's force into displacement, that is in the direction of force. So formula here it's applied is work done, that is W, is equal to force, that is F, into displacement, that is S. Now where W is once again it is work done and the unit is joule, which is denoted by capital J. For force it is F, unit is Newton, denoted by capital N. S is displacement, denoted by small m. Now what is the important idea behind this? That if it is more force, that means definitely more work, and if more displacement, that means the more work is done. So what you see it on the screen here, this boy is applying a force. Where? To this object, towards the right, and the displaced object which was here, now the object is here. So that means the force which is applied in the direction of force and the object is being displaced. What is the unit of work? SI unit, that is joule, denoted by capital J. Now 1 joule is 1 Newton into 1 meter. Now 1 joule will be equal to what, students? 1 Newton, that is 1 N into 1 M. Meaning that 1 joule of work is done when a force of 1 Newton moves an object by 1 meter in its direction. So this definition is extremely important related to your exam. So here if you can see it on the figure, that is 1 Newton moves an object by 1 meter. Now when we talk about the graph, many a times students they have a lot of doubts related to this. Let's understand force displacement graph. Children, if you have to calculate the work done in this, please remember it is area under graph. For constant force, area when we talk about, that's suppose we say rectangle. For work done, as we know, it is force into displacement. So 10 Newton force over 1 meter. So work is 10 joules. So looking at the figure, if you understand, if your teacher tells you to calculate work done, please remember it is area under the graph. Now when we say area under the graph, so again I'm repeating it, it's a rectangle. So this part, right? And we know the formula, that is what? Length into breadth. Now when is work 0? Suppose case 1, force is 0, work will also be 0. If displacement is 0, work will again be 0. For example, pushing a wall. Or when we talk about force which is perpendicular to displacement, work will be 0. In that case, like example is carrying a school bag horizontally. If you look it on the screen here, now the wall which is being pushed, now wall is there only. That means what? The force which is applied, but the work done is 0. That means there is no displacement. Positive and negative work. Now when we talk about positive work, students, that is force and displacement, they are in the same direction. Let's understand with example, like you're pushing a wheelchair, you're pulling a trolley. So work done, when we talk about here positive work, that is greater than 0. What about negative work? That is force which is opposite to displacement. For example, braking a car or goalkeeper stopping football. So here work is less than 0. So you can see it on the screen here, the positive work, force which is applied and the motion, so work done is greater than 0. For the negative work, if you see friction and the motion opposite side, so work done is less than 0. Now what do you understand by the term energy? Energy means capacity to do work. For example, moving cricket ball, raised flower pot, stretched rubber band. So what is the unit? Unit is joule. So likewise for the work done also the unit is joule. Now let's understand some important concept related to work energy theorem. So work done, children, you need to remember it's extremely important. That is change in energy. I'll repeat again. What is work done? That is change in energy. Formula will be delta E. What is delta here? If you see this triangle, it is termed as delta. That means change in energy. So positive work, that means energy increases, and negative work, energy decreases. There are different forms of energy. One is mechanical energy, electrical energy, thermal energy, light energy, sound energy, chemical energy, nuclear energy. That means energy, please remember, can change from one form to another. There are certain pictures on the screen that will help you to understand how the energy can be changed from one form to another. Mechanical energy and kinetic energy. Energy due to motion, position. So when we're talking about mechanical energy, there are two energies which comprises, that is kinetic energy plus potential energy. So energy possessed due to motion. So what is the formula for kinetic energy? Half mv squared, where m is mass, v is velocity, and what is the unit? Joule. Children, as I told you in the previous slide, work done is equal to joule, and the energy work done is equal to energy. So the unit for both the quantities are same. What are the facts about kinetic energy? Please remember it depends on mass, depends on square of velocity. That means if the velocity doubles, so kinetic energy becomes 4 times. Now these type of questions are asked in exam related to facts about kinetic energy. And if velocity triples, what happens? Kinetic energy becomes 9 times. Potential energy. Now here energy that is due to position or shape. And when we talk about motion, that is kinetic energy. For example, raised ball, compressed spring, stretched rubber band. So this is all about potential energy. Or even the example drawn bow. Next, we have gravitational potential energy. Now, the formula for gravitational potential energy is m into g into h. Now, what is m? That is mass. Small g, gravity. H is height. So, what is the unit here? Again, the unit is joule, denoted by capital J. So, observation here, if you understand what exactly the concept behind gravitational potential energy. So, greater the height, greater is potential energy. Conservation of mechanical energy. Now this law, when we understand, please remember that mechanical energy remains constant. Now when we say mechanical energy, that is potential energy plus kinetic energy, which is constant. So during falling, what happens? Potential energy decreases. Kinetic energy increases. So total energy remains same. So looking at the figure on the screen, if you see, we're talking about the height and small g. Now the important concept, students, you need to remember related to falling object. So if we understand about falling object, so potential energy will be maximum there. Kinetic energy is 0. What about the object when it reaches the middle position? So potential energy decreases, kinetic energy increases. And when it reaches to the bottom, potential energy is 0 and kinetic energy is maximum. Likewise, when we talk about pendulum energy, at extreme ends, potential energy is maximum, kinetic energy is 0, and at center, potential energy is 0 and kinetic energy is maximum. So what do we actually derive from this or conclude? Energy continuously changes, potential to kinetic and kinetic to potential. So looking at the screen, it's a request, students, that you pause and just note it down so that you understand the concept that how kinetic energy actually works and what is it in the middle position, and when it reaches to the bottom, what is the role of it. Now next topic is power. What is power exactly? It is the rate of doing work. And what is the formula? When we say rate of doing work, that means work upon time. W upon T. What is the unit? Unit is watt, which is denoted by capital W. Unit of power, again repeating it, it's watt. So what is 1 watt? That is 1 joule upon second. Now how did we get the 1 joule? Please remember that the unit of work is joule and for time it is second. That means if 1 joule work is done in 1 second, so power is equal to 1 watt. You can look at the screen, you will understand more in detail what exactly the power is. Next topic is simple machines. Now, simple machines, when we talk about children, every single day we are using these devices and that make our work easier. That means they change the force magnitude or they change the force and direction. Or when we talk about they do not reduce total work, so that you need to remember what exactly the machines are. Now, the next important term, what you have to remember when you are starting with simple machines, that's mechanical advantage. Now, what is mechanical advantage? That is load upon effort. Now, if you understand here, please remember that mechanical advantage greater than 1, that is machine makes task easier. So look at the screen, you will find different examples here: lever, pulley, wheel and axle, inclined plane, wedge and screw. What is pulley? Now, pulley, when we talk about, we also term it as a fixed pulley, or there are different varieties to understand what exactly the pulley is. So changes the direction of force only. Now here, mechanical advantage when it is 1. For example, let's talk about flag hoisting or well bucket. And what is the advantage? Definitely it's convenience. Next is your movable pulley. Now what does it do? It reduces effort, lifts heavy loads. Now what about the mechanical advantage here? Children, when we are talking about mechanical advantage, we are talking about load upon effort. So here, movable pulley, mechanical advantage is greater than 1. So example can be more in detail. We understand that. Cranes, elevators. So on the screen, if you see, one is the fixed pulley, this one, and the second is the movable pulley, which reduced effort. Inclined plane. Now, inclined plane is basically a sloping surface used to lift loads. For example, ramps or hill roads, staircases. So what is the advantage? Less force is required. Mechanical advantage of inclined plane. Now, going further, let's understand this. This is mechanical advantage is basically equal to length upon height, that is L upon H. And what is the key idea behind this? It's a longer ramp and smaller force needed. So looking at the screen, if you understand here, the object is here, the force, that's the effort which is applied above. This is length and height. What is the principle behind lever? A rigid bar rotating about a fixed point. So parts are fulcrum, effort, load. Now these terms you need to remember, students. So if we talk about crowbar or we talk about seesaw or scissors, what is the principle behind this? It is effort into effort arm, which is equal to load into load arm. So what is the formula here? E into EA is equal to L into LA. So looking at the figure, hope you understand the effort. Like here, if it is the effort which is applied, this is the load, and the fulcrum, which is the middle point here. Mechanical advantage of lever. So mechanical advantage is equal to effort arm divided by load arm. So what is the conclusion basically? You need to understand the basic concept. Longer effort arm, smaller effort required. So types of levers, they are class 1. Fulcrum is in the middle. For example, seesaw, scissors or pliers. What about class 2? Load in middle, for example, wheelbarrow, bottle opener. And class 3, that is effort in middle, for example, tweezers, broom, fishing rod. So looking at this, I'm very sure it will be clear to you when we talk about different types of levers. So what are they? Once again, it is class 1, class 2, and class 3. So you need to understand that fulcrum is middle in class 1, load is middle in class 2, and effort is middle in class 3. Quickly to summarize, these are the basic points which we have taken in this chapter, part 1 video. So work is force into is, that's just quick recap. Work energy theorem is W is equal to delta E. Then we have seen the formula. Kinetic energy is half mv square, potential energy is mgh, and power is work upon time. Mechanical advantage is load upon effort. So this was the summary for this chapter, taking the basic points related to work energy and simple machines. And in part 2, we will be studying more in detail about the application of these formulas. Thank you and take care.